Shark is the section for Bio 185 Zoology at Golden West College. Represent! I got two smoothhound sharks here. Pre-reproductive. In other words, I try to get them if they're not old enough to reproduce. She's probably about 3-4 years old. He's probably 2.5 to 3 years old, based on the size. They're local to our waters, so you can go out and catch these and then dissect them. No, usually I just catch them and then release them. So we have a male and a female, and how do I know it's a male and a female? Well, I read the bag, and then I looked at the pieces. So this is a pelvic fin of a female, and so the male not preserved well. So we're not gonna look inside him. I tried to open him up and it made this cracking sound. It's not supposed to. So we're not looking inside him, but you can see his pelvic fins are equipped with things like, oh, look at that. That's a male. What a male, right?
A male. He's got two of them.
Two of them. Those are called claspers. Claspers, and they're analogous to the penis. And he has two, and I'm touching them.
So the female doesn't have that at all?
No, look, she just has fins. There's nothing on there. So she can get fertilized. She can get fertilized on left and right sides. So that's why he needs to have two delivery devices. Delivery devices, right? So he can get her pregnant on two sides at the same time. He's a player. He's a shark. We have the dorsal side. It's darker than the ventral side. What's that called?
Counter shading.
Not you. You already know. Counter shading. And you're just for looks now. Okay. Here we have a hole on the top of the head. It's called spiracle. When the shark sits on the bottom of the ocean or wherever it's on, when it brings water into its gills, it doesn't want to get a mouthful of sand. So it can switch from bringing water from the mouth to bringing water in by way of the spiracles. So it allows them to bring oxygenated water into the gill chamber without getting a mouthful of sand. And here's a dorsal fin. Now, the previous group learned that dorsal fins are known to change the color of water to red. Because typically if you see a dorsal fin, then the water turns red shortly thereafter. You wonder what happened. I tell the same joke every time. Here we have a tail. How would you describe this tail? How would you describe the tail? Heterocircle tail. How do you know? Because it goes up into the dorsal lobe. Now, so what kind of fin is this on the tail?
Caudal.
Caudal. Yeah, it's caudal fin. And this species doesn't have an anal fin. Some sharks do. So I already did pelvic fin. Here's pectoral fins. Hello. She can't talk. Her heart's exposed. Up on the ventral surface here by the head, we've got a couple of things. If only I had a pointer that wasn't a blade. There's a nostril. A nostril right here. They don't use them for breathing. They use them for they use them for smelling only. And then if you're Kevin, you got a front row seat for this. If you're not, then you won't even see it. All these freckles right here.
Oh, now I can see them.
Yeah, all these freckles. All those freckles contain sensory structures known as ampullae of Lorenzini. So the ampullae of Lorenzini are sensitive to electrical fields. In other words, they can feel electrical fields. And physics tells you that every time you have ions in a medium that flows around something, it creates an electrical current. Maybe very mild, they can sense that. So if this shark swims over, let's say there's a fish hiding under here, like a purple fish hiding under here, and the shark swims over the top, he can feel the presence of that fish. It's pretty cool. Just there. Jedi. All right. This is my friend. We named him Dissecting Pins, and he's going to hold this open for me. Now, if we open up, we see this kind of silvery lining here. That's the peritoneum. And Kevin, how would you describe that viscosity? How does that feel?
It is so slippery.
So slippery and slimy. Here's the liver. And then here's the liver. In semesters past, I've taken the liver and flapped it on the person's arm. But because it's carcinogenic. I know, right? They died.
Slowly.
Painfully. Here's the stomach. So it's a big stomach, right? Oh, I forgot something. Oh, the previous group, they're so well. I mean, sure out of luck. Because I forgot to open this and show a structure. What did I forget to show inside the... Yeah, Kevin, dude.
What? I didn't know.
Abdullah, he was checking my work. Huh? No. I failed to show the rugae. You open up the stomach and you see the wrinkles.
Folds of the stomach.
Folds of the stomach. They're called rugae. They allow the stomach to expand. They also increase surface area inside the stomach. So in case you want to secrete enzymes.
Red Ranger outside.
I know. I thought it was at first. But then she's not coming over here. She didn't look like she was doing kung fu. And then here we have the rest of the stomach, and there's a lot of fat covering it. And then we have this, see that little, that's called the duodenum. It doesn't always go, but sometimes it does. And then here we have the spleen. does the same thing a human spleen does, takes apart red blood cells. And then if we look in the membrane here, we can see a piece of the pancreas, that kind of tan-colored thing. This is gray. Inside the mesentery is called pancreas. Pancreas has two parts. There's the other part right here. So 2 parts of the pancreas. And then this is homologous to the intestine. We call it the ileum because it's special. It looks kind of short, right? Too short for proper digestion. Well, if we open up the ileum, we can see that membranes go across the middle there like that? Look at that. It's called the spiral valve. It forces the food to take a spiral route through this organ, so it doesn't just go straight through. Instead, it has to go around and around and around and around and around and around. So on the outside, it's like 6 inches. On the inside, it's probably 1.5 feet. It's pretty cool, right? You got to get around having a surface area. Here we have the rectal gland.
Near the rectum.
Near the rectum. It's a gland near the rectum called the rectal gland. There it is. Ew. This is the membrane out here. Go, membrane, go. Oh, it's a glove. Okay, there's the rectal gland, and it's in charge of chemical communication with other sharks. This shark takes the pooper pee, and then this extracts a little bit of its chemical into it, and then it smells like Fred peed there. As opposed
Fred
to just
the female.
Fred the female, yes.
Yes.
It's a strange name for a female. Let's fold the liver back down. This
here.
liver is giant, and I'll talk about why it's giant when we get to it in lecture in August. And yes, I'm looking for a good pointer. Here's a good pointer. Okay, so we're going to go into the pericardial cavity. Before we do, we're going to cross a membrane here called the transverse septum. It is analogous to the diaphragm. It's not muscular. It doesn't do what the diaphragm does, but it does separate the abdominal cavity from the pericardial cavity. The most obvious structure in the pericardial cavity is the ventricle. Remember I said the ventricle is the big muscular part of the heart. Emerging from the ventricle anteriorly, we find the conus arteriosus, slightly different name from what we saw with the other fish. And then here we have the atrium, this soft, kind of looks like a sac there. That's the atrium. And if we fold, I'm just going to go out and brace off your arm. If we fold the heart forward a little bit, we can see a triangular structure, and I'll just point with anything. A triangular structure right there, that's called the sinus venosus. So blood collects at the sinus venosus, then goes into the atrium, then to the ventricle, and then to the conus arteriosus. Now let's do, since we did heart, might as well do reproductive structures. This is a female. Where do you think the reproductive structures should be? Well, if the claspers go in here, then they should be over here somewhere, and they're not. The reproductive structures are here. This is the ovary. Let's point with a pair of scissors because that's fun. It's a ovary right there. She's an immature female. I'm blocking him, sorry. I'm just going to...
Tell me what's that?
Well, I'm just going to try to isolate it for him. There's the ovary. Immature, there's no eggs in it, no mature eggs. That's what we wanted because we don't want to have too much of an impact on the environment because this is a wild-caught animal. If we go over to the other side, we can see another ovary right here. The testes would be in the same location. They would look kind of the same. So if we open up the male and looked in that area, we see something very similar. Great spot for the reproductive organs. If your reproductive organs become dysfunctional, they can't function anymore, evolutionarily, you might as well be dead. Well, how could these get damaged without this animal being dead anyway? So it's a pretty good place. You protect those, right? Those are important. And this space in here, of course, is the coelom. The membrane I was fighting with the whole time was the mesentery. So if we can expose the mesentery here. Look at the mesentery. Wow. And then this is the peritoneum. And I think we got, we forgot lateral line. Glad you said lines. I know that's not what you were talking about.
No articulation.
Okay, here's the lateral line right here. You can see it better here, and then off and on. And scene.